Welcome to a special episode of Doug's Electronic Repair Bench.
Morning YouTube, here with you on this Thursday morning. Going to get into the troubleshooting special video here in just a second. Just wanted to show you what kind of day it is. It is a beautiful day out there. I mean, absolutely gorgeous. High's supposed to be 70 today. Like I said, it's just gorgeous. I love this kind of weather. I love spring weather. So, anyway, now that you've seen that, throughout this video coming up, I'm going to be using some computer-generated images, which will be displayed on the screen. I'm trying to get this set up to where I noticed the one I did yesterday didn't look that good in the video, so I'm trying to make these images to where they appear better in the video and more clear, I should say. And so we'll see how that works. But mainly I'm going to show exactly how I've got the radios connected to the isolation transformer and show you images there of how the power supply is connected. And just so as a reminder to be safe. And I probably won't say much more about the safety today because I pretty much covered all those aspects yesterday. Today I actually want to get into the crux of the matter and see if this idea of mine of signal borrowing is actually a practical method of troubleshooting a radio. So let's get into it now and go into the workbench and see what we got going. Alright, before I begin here, I want to show you exactly how I did this, keeping these radio chassis plugged in the same way. What I did was find the prong of the plug which connects to the B source, which is on the power switch. Okay, on both radios. And I marked it with an X on the prong there, as you can see. And I've got those plugged in both the same way to make sure I'm doing it right. I'm plugging into the X mark goes into the cold side of the socket. Now on a transformer or isolation transformer, it doesn't really have anything to do with it, but at least it assures that they are plugged in the same way. So that's what I wanted to show you to begin with. Now for this demonstration, what we're going to try to accomplish is the fact that we can use, or hopefully can use, one radio to, one working radio I should say, to troubleshoot another non-working radio. And to do that, what we're going to do is borrow our signals from the working radio and try to use them on the non-working radio. So basically, we're going to go over this one step at a time, and I just want to show you how we're doing it. This is a 0.01 capacitor. Okay, that's the value of it, and I've got it on 2 clip leads. You can see there's the other end of them right there, and what I'm going to use is, that's what I'm going to use between the radios, so as there's no direct connection between the 2 radios, okay? And let's turn everything on here. Let's get the Variac hot and get it back up to proper voltage. For our purposes this time will be about 120. There we go, 120. So we are hot, live, or whatever you want to call it, and both radios are on. This is the working radio on the. Let me show you this. This side is the working radio. As you can see, I turned it up. Okay, I'm going to find a talking station.
Supporting themselves. I mean, I thought all three actresses in Hidden Figures.
Alright, now that's a talking station. I'm going to leave it to there. Basically, what you want to try to find is a good, strong station.
Don't belong in.
You don't want to use weak stations because you don't get a good signal from those.
That may be a strategic backfire if it might do.
Now, the radio on the other side, I'll show you that. Right there. This is the, that's tuned to, or it's switched to FM. And you can hear there's no station there, okay? Now I'm going to turn the volume up about halfway. So what I'm going to do is go back to this side. And I'm going to, like I said, you can hear the volume.
You know, obviously that means...
Now I'm going to turn that down. The volume is down on that. And the point I'm going to inject into is... We know that the audio is there. We can hear it when we turn up the volume. But I'm going to use this schematic here to inject a signal into the audio section of the radio to be sure of what we are seeing or hearing, I should say. Alright, we're going to start at the beginning here. We're going to use the audio from one to test the audio of the other one. So what we're doing is just basically putting it in this way here, and we'll hear what the difference is. When I touch right here, okay, we can hear the audio from the other radio coming across on the non-working radio. So the audio section is actually working. We understand that. So the next thing we want to do is go back further in the chain to find out where we have it at, or don't have it at, I should say. So let me look that up in the good place in the chain to do that. I think we'll go back to the between the two IF stages would be a good spot, I think. I have got a bad clip lead and I'm trying to compensate for it. Let's get a different clip lead. I hate this one. Now they're both red. That'll work out really good. Alright, now let me show you what I've got here. I'm on the, I'm going to show this on the diagram first, and then you'll see where I'm connected. So I'm in about the middle way of the IF chain, so you see it on the non-working radio there. And there's the other one right there, that's the working radio. And again, we're connected via 0.01 cap. So now there you go. We have it that far back, so we're in the middle of the IF, and the radio is working fine on here. So we know the problem has to be before that. So we're going to go one more time. We're going to go back. This time we'll go to the end of the IF. In other words, to the oscillator, mixer oscillator, and see what we get there. So hang on there.
The director of OJ.
Okay, we've got it. Let me point this out.
Despite there's a lot of debate.
We're back at the
about whether or not you can actually consider it. It represents.
Okay, we're hooked up to the third IF input of the third IF here.
will speak
So,
to.
you can hear we have it right
technical
there,
errors in a way
okay?
that the other films might
That's no
not.
problem there. So, the IF stages of both radios are working fine, and we can clear that from our list. So, let's go back to the a little further, see what we can find. Alright, now you can see. Okay, now you can see that we are hooked up on the collector of Q1 on both radios. There's the other one. We get no sound. So what that's telling us right there is our problem is between that point and the beginning of the IF chain, which would be the mixer stage. So that pretty much tells you that the problem is in the mixer stage. So we can demonstrate that a little further by doing this, and I'll show you what I'm talking about. Okay, now for this little demonstration, I am connected to a test point, which I'm going to show you right there. That is the reverse AGC, is what that's called on the thing. And I've just got the test point on the working radio hooked up, and here is the lead for the other thing, and I'm going to show you what I'm talking about here. We're going to put this right next to the oscillator stage right here and see what happens.
Fox News reports Alan Combs has passed away at the age of 66.
So you can see
he would sometimes be absent from the show to deal with what he referred to as
I'm just touching the outside of the, I don't even have to touch it, just get it close to that transistor. That's the mixer transistor. And so if we put that signal into that reverse AGC, which is signal from the other end of the what do you call it, the signal of the IF, it works fine. So our problem is in this here mixer. Now I think by just touching the, that seems to work. So I think the oscillator is the only thing that's not working. What I'm thinking is the transistor itself is working. The amplifier section of that transistor is working, but I don't believe the oscillator is working because we can't tune in stations. So a problem probably is, like I said, in that that section right there. So like I said, that's how you use one radio to troubleshoot another radio. So all you have to do is find that stage that the problem is in, and then you can go from there. And I think if from troubleshooting the other radio and finding the bad resistor, I think that will be the first place we'll look on this radio here and see if that tells the tale or not, and if it doesn't, we'll go from there. But like I said, that's what we're going for, and I think we proved pretty much that you can use the another radio to troubleshoot a non-working radio. And I think it's actually a good method to use. The signals are the same in these radios. Now these happen to be, let me turn this off. These happen to be identical radios. And I think if I do another one of these, which I may do, I may use a different radio. Basically, I use a tube type radio and try to use that to do the same exact thing. Inject signals, or borrow signals I should say, from one radio to troubleshoot the other one. And this should work for any radio. The main thing you want to remember about this procedure that we have done here is this capacitor in between the leads, okay? I'm sure you can see that, guys. We don't want a direct connect between the two radios. We don't want that at all. And so this is the method that I used. Like I said, it's a 0.01, just a simple regular old capacitor. It's nothing special, but it does isolate the two, the DC from each other, and allows you to transmit signals from one to the other with no problem. As you can see, there's no ground connection, and doesn't need to be any ground connection. It's not a problem when we're dealing at signal level like that. And so I think that's the answer to the people that don't have any real test equipment, or have limited test equipment, I should say, I guess. Maybe don't have a signal generator. This makes a great signal generator for another radio. As you can see, it did work just fine, and I think that's a pretty good demonstration of how it works. So I think we're going, with that, I think we'll end this video, and you guys have a great day. Thanks so much for watching. See ya.